Finishing up Unit 4, or Unit 2, Notes 4. So we're going to do the second part of that note sheet. So first of all, we want to go over the different steps to solving systems by elimination. So we talked about some of the steps in the first part of the video. And one of the first steps is to put both equations in standard form. That's the same as the front page. Okay, then we want to multiply one or both of the equations by a number so that the variable has opposite coefficients. Remember, we're looking for same number, opposite sign. Same number, opposite sign. So that might require us to actually multiply a number. So this is where knowing your multiplication is going to come in handy. The next thing you're going to do is add the two equations together, and one of the variables should cancel. Now, if one of the variables doesn't cancel, that means you did something wrong. Then you're going to solve for the remaining variable, and you're going to substitute that value into one of the equations and solve for the other variable. So that's kind of the process we're going to be working through on this next part. So let's go ahead and let's take a look at number 1. So for number 1, I noticed that my x's both have the same number on the outside. So all I have to do is make one of them an opposite. So to make it an opposite, I'm going to multiply that bottom one by a -1. And that means I'm going to change the signs of everything in that second equation. So my top equation stays the exact same. And my second equation, I am going to flip all of the symbols. So x minus x is going to cancel out. 2y minus y is going to give me y, and then 10 minus 6 is going to give me 4. So now I know that y is equal to 4, so I can plug it in there or there. Remember, it doesn't matter which one you plug it in for. So I'm just going to plug it into the bottom one. So then I end up getting x plus 4 is equal to 6. So now I'm going to go ahead and solve this for x. So I'm going to subtract 4 from both sides, and I get that x is equal to 2. So now I want to write my coordinates out as a coordinate. First my x, and then my y. So this right here is my solution for number 1. Now, let's take a look at number 2. So if you look at number 2, you can see that we don't have the same numbers on any letter. So then what I like to look for is any number that has a 1 out in front of it, or basically no number out in front of it. So since there's a 1 outside of that y, it makes it easier. So I see that this has a positive 2 on it. So what I'm going to ask myself is, what's the opposite of a positive 2? Well, that's going to be a -2. So I'm going to take this second equation and I'm going to multiply it by -2. So I have 4x plus 2y is equal to 8. That's going to stay the same. And now I'm going to multiply this bottom one by a -2, because when I take 1 times a -2, I get the opposite of that guy there. So I get -6x minus 2y is equal to a -16. So now I can go ahead and add down the columns. 4x minus 6x is -2x. Your y's cancel out. -16 plus 8 is going to give me -8. So then I'm going to go ahead and divide both sides by a -2. Now when I do that, I end up getting a positive 4 because I divided out two negatives. So you'll see now we can plug in our x, and we can plug it into this new version, this, or this. It actually doesn't matter which equation you plug it back into. So I'm just going to plug it in to the original bottom one. So I'm going to do 3, and instead of writing x, I'm going to put a 4. So 3 times 4 plus y is equal to 8. So then I get 12 plus y is equal to 8. Then I'm going to subtract 12 from both sides, and I end up getting that y is equal to a -4. So then my point is going to be 4, -4 as my solution for number 2. Now, let's take a look at number 3. Again, we need to create same number, opposite signs. Well, what I notice on this one is that my y's already have opposite signs. So I'm going to start there. And then I'm going to ask myself, okay, what's the smallest number that 3 and 10 both multiply to? Not divide by, but multiply to. So the smallest number that they both multiply to is 30. So then we're going to take, and I need to ask myself, what can I multiply -3 by to get 30? And that's going to be a 10. So I'm going to multiply this first one by 10. Then I'm going to ask myself, what can I multiply 10 by to get 30? And that's going to be 3. So I multiply the top one by 10, the bottom one by 3. So when I multiply the top one by 10, again, you're multiplying all the way across, including what's on the other side of the equal sign. And then 30x plus 30y is equal to 90. So now I'm going to go ahead and add down my columns. Well, 20x plus 30x is going to give me 50x. My 30s are going to cancel out because I have the same number with an opposite sign. 110 plus 90 is going to give me 200. So now I'm going to divide both sides by 50, and I get that x is equal to 4. So now I know that x is equal to 4. Remember, you can plug that into whatever version that you want. So I'm going to plug it into the original top. I'm going to take x out completely and put 4 in instead. And then I'm going to have minus 3y is equal to 11. So 2 times 4 is 8. Minus 3y is equal to 11. So now I'm going to subtract 8 from both sides, and I get a negative 3y is equal to 3. Divide both sides by a negative 3, and I end up getting that y is equal to a negative 1. So then the point is 4, negative 1. So that's my answer for number 3. Now, let's take a look at number 4. So I'm noticing that none of them have opposite signs. So now I want to look for numbers that are easy to multiply to. Well, for example, I know that 4 multiplies into a 12. All I have to do is multiply by 3. So then I ask myself, okay, what's the opposite of a negative 12? Well, the opposite of a negative 12 is going to be a positive 12. And then I ask myself, how can I take negative 4, and multiply it to a positive 12? Well, I do that by multiplying it by a negative 3, because remember, a negative times a negative is positive. So up top, I have negative 15x plus 12y is equal to a negative 90. Then my bottom is going to stay the exact same. And now I can go ahead and add down the columns. Negative 15x plus 12x is negative 3x. My y's are going to cancel, and negative 90 plus 96 is going to give me 6. So now I can go ahead and divide both sides by a negative 3. And that gives me that x is equal to a negative 2. So then what I want to do next is plug that x is equal into negative 2 into whichever one I want. So I'm going to plug it into the original top. I'm going to take x out and put negative 2 in instead. And then minus 4y is equal to 30. So I get negative 10 minus 4y is equal to 30. So I'm going to add 10 to both sides, and I get that negative 4y is equal to 40. So to solve for y, that negative 4 is being multiplied by the y, so I'm going to go ahead and divide both sides by negative 4. And when I do that, I get that y is equal to a negative 10. So my x is negative 2 and my y is negative 10. So my solution is negative 2, negative 10. Now let's go ahead and let's take a look at number 5. So for number 5, we need to actually figure out what we need to multiply to get our opposite, or our same coefficients. I see that n already has opposite coefficients. So now I need to figure out what the smallest number that 5 and negative 3 multiply to. So the smallest number that 3 and 5 multiply to is 15. So what do I need to multiply 5 by to get 15? Well, I need to multiply it by 3. So I'm going to go ahead and multiply that whole top by 3. What do I need to multiply 3 by to get to 15? Well, I need to multiply it by 5. So now we're all ready to go. So what I'm going to do is I'm going to multiply the top one by 3. Plus 15n is equal to 15. And then I'm going to multiply the bottom one by 5. So I get 15m minus 15n is equal to 120. So now I'm ready to add down the columns. So 30m plus 15m is going to give me 45m. 15 plus 120 is going to give me 135. So now I can go ahead and divide both sides by 45. And when I do that, I end up getting that m is equal to 3. Now remember, you can plug that m into whatever version you want. So I'm going to go ahead and I'm going to plug it into the original bottom. So I'm going to take 3, and then instead of writing m, I'm going to take 3. Then minus 3n is equal to 24. So then 3 times 3 is 9, so I get 9 minus 3n is equal to 24. So then since that's a positive 9, I'm going to subtract it to get it over to the other side. So I get a negative 3n is equal to 15. Divide both sides by a negative 3, and I end up getting that n is equal to a negative 5. Now, since this isn't x and y, it's not as easy to put it in a coordinate point, so I usually tell students just to put it in alphabetical order, or you don't have to put it in a coordinate point if it's x and y. So let's go ahead now and let's take a look at number 6 here. So when we're taking a look at number 6, I see that my y's already have opposite coefficients. So I need to figure out what the smallest number that 21 and 9 multiply to. So if you don't know, start multiplying around on your calculator. Make some guesses. And so after doing that for a while, I found out that the smallest number they multiply to is 63. So what can I multiply 21 by to get 63? Well, I multiply it by 3, so I'm going to multiply the top equation by 3. And what do I multiply negative 9 by to get to 63? Well, I multiply it by 7. So I multiplied the top one by 3, and I got 42x plus 63y is equal to 42. And then when I multiplied the bottom one by 7, I ended up getting 21x minus 63y is equal to 51 times 7, which is a negative 357. So now I'm going to go ahead and add down the columns. So 42 plus 21 is going to give me 63x. And those are going to cancel. Negative 357 minus 42, plus 42, is going to give me negative 315. So now I'm going to go ahead and divide both of those by 63. So when I divide them both by 63, I ended up getting that x is equal to a negative 5. So now I know that x is a negative 5, and I can plug it into whichever one I want. I'm going to actually plug it into the bottom original. So I took x out and I put negative 5 in instead. And 3 times negative 5 is negative 15. Minus 9y is equal to negative 51. So since that's a negative 15, I need to add 15 to both sides. And when I do that, I get negative 9y is equal to negative 51 plus 15, which is negative 36. Divide both sides by a negative 9, and I end up getting that y is equal to 4. So my coordinate point then is negative 5, positive 4. That is my answer for number 6. Now, let's go ahead and let's take a look at some of these word problems. So number 7 says that Dante spent an $11.25 on 3 new and 4 old comic books. So I'm going to let new be X and old be Y. Samantha spent $15.75 on 10 old, now remember that old is Y, and 3 new ones. Write a system of equations that represents the amount of money each person spent on comic books. How much does each type of comic book cost? So we have 3 new ones at price X plus 4 old ones at price Y, and that's equal to $11.25. Well, then Samantha got 3 new ones at price X and 10 old ones at price Y, and that was equal to $15.75. So now we do have this set up for our system. So what we need to do is make opposites. I see that X already has a 3 with it. So what I'm going to do is I'm going to multiply the bottom one by a negative 1 to create opposites. You could multiply the top one if you wanted to as well. But you want to do one or the other, not both. Because again, we're trying to create opposites. So the top stays the same, and then I'm going to change the bottom, everything, including what's on the other side of the equal sign. That's going to become negative as well. So now I'm ready to add down my columns. Well, 3x minus 3x is going to cancel out. 4 minus 10y is negative 6y. 11.25 minus 15.25 is negative 4.5. So now what I want to do is I want to divide both sides by a negative 6. And when I do that, my negatives are going to cancel, and I end up getting 0.75. So it's 75 cents. So I want to label it with money, but I also want to say old, because I want people looking at it to know that that represents the price of old comic books. And now I want to put in the price for new comic books. So what I'm going to do is I'm going to use the original top equation, and instead of writing y, I'm actually going to put in 0.75. Okay, so then I get 3x is going to stay the same. 4 times 0.75 is 3, and that's equal to 11.25. So I'm going to subtract 3 from both sides, and I get that 3x is equal to 8.25. Divide both sides by 3, and you get that x is equal to 275. And again, I'm going to write new so that it indicates that that is for new comic books. Okay, so let's take a look at number 8. So for number 8, it says that Amy is walking in a straight path that can be represented by the equation negative 2x plus y is equal to 3. At the same time, Kendra is walking in a straight path that is set by the equation 3y is equal to 6x plus 6. At what point will the two girls be in the same place? So I need to take this second equation right here, and I need to actually get it into standard form. So I have 3y is equal to 6x plus 6. So I'm going to go ahead and subtract 6x from both sides. Now I can't add those two together because they have different letters. So I get negative 6x plus 3y is equal to 6. That's for Kendra. Now I'm going to go ahead and I'm going to combine Amy with that. Okay, so now I want to figure out at what point they will be at the same place. So what I'm going to do is I'm going to go ahead and make opposite signs. So I see that this y has a positive 1 on it. So then I ask myself, okay, what's the opposite of a positive 3? Well, that's going to be a negative 3. So what I'm going to do is I'm going to multiply this bottom one by a negative 3. So my top one is going to stay the same. Then my bottom one is going to become a positive 6x minus 3y is equal to a negative 9. Well, this cancels and this cancels, so I end up getting 0. 6 minus 9 is going to give me a negative 3. So what I have here is a no solution situation. So I have no solution because I don't have a true statement. Well, what does that mean in terms of the problem? That means that they don't cross each other. So they're actually walking parallel to each other. Okay, so that's the answer for number 8. Next, let's take a look at number 9. A shipment of TVs, some weighing 30 pounds. Oops. That's fun to see, isn't it? Okay, so some weighing 30 pounds and others not. I'm done. There we go. Okay, so then what I want to do is this will let me. We want to say that our 30-pound TVs are X and our 50-pound TVs are Y. So for every X 30-pound TV and every Y 50-pound TV, it's going to weigh a total of 880 pounds. Okay, and there's 20 total TVs together, so that means X plus Y needs to be 20 TVs. So now what I want to do is I want to solve this using elimination. So what's the opposite of a positive 30? Well, that's going to be a negative 30. So what I'm going to do is I'm going to multiply that bottom equation by negative 30 so I can maybe cancel out my x's. So I get 30x plus 50y is equal to 880. And then negative 30x minus 30y is equal to negative 600 when you distribute that negative 30 all the way across. So now I'm going to go ahead and add down the columns. Well, my 30x's are going to cancel out. 50y minus 30y is 20y, and 880 minus 600 is 280. Then I'm going to go ahead and divide both sides by 20, and I get that y is equal to 14. Now y is equal to 14 50-pound TVs. Remember we talked about labeling it and making sure each person knows what each answer represents. So that's y. And I know that the total number of TVs has to be 20. So the 30-pound TVs plus 14 needs to add to 20. So I'm going to go ahead and subtract 14 from both sides, and I get that x is equal to 6. Now that's going to represent my 30-pound TVs, so I want to make sure I label that. So that right there is my final answer for number 9, and that concludes this note video. Thanks for listening.